how to build column splice connection. We have a column splice connection here. We will explain how to build this connection. From the connection builder, if you click the help file, in the samples we have a ColumnSpliceSample. This sample shows a customer column splice. It's from chef steel. You can see from the picture we have a prep for the top upper column, and we have a web connection, play and bowl lifting hole, and this is a quite standard regular. We have erection 8. We have 4 of the erection 8. They looks exactly the same except on the different location, and they are symmetric. So if using regular way, we have to build 4 of them, and each of them we need 2 bowls for erection bowls, 2 plate and 1 angle. So it's, if you want to repeat 4 of them, it's a lot of work. So the ideal way is we build a sub connection. This connection is only create bowl, plate and angle for one of the erection 8. Then we can apply them 4 times with their different location, so they will finish the job. By define erection 8, we need define 2 plane. As you can see, plane 1 and plane 2. So the input for the sub connection, let's go to connection builder. We have erection 8 built already. We call it sub column erection 8. Load this connection. You can see we have 2 connection parts. That is upper and lower column. Then we have 2 points. In here, the point actually is 2 vector, as we can see from the help file. Because we can't input a plane, so we give 2 vector, like say this vector 1 and this vector 2. So using these 2 vector, we can define the plane. Let's see, we have the bottom bowl, bottom hole, and top bowl, and the bottom play, top play, and angle, and plus 3 wells. Let's see the first bowl. We have plan A and plan B defined. Let's see the definition of the 2 plane. We have plan A get edit, so we can see the definition. The plan is check the direction of part 2, this upper column. So check the near out plane and far out plane. So that is the plane flash with the toe of the flange. So check its near side or far side by the direction of the pick point 1, that's the input vector. So if the input vector is on the x plus direction, then it will be near side, near out plane. If they are x minus direction, it will take the far out plane. And same is the plane B. That is check the part 1. Part 1 is the lower column. So by this direction, they will check if all the outside planes could be top, bottom, near side, and far side. So actually, it's supposed to take top or bottom plane. So using these two planes, we can define the origin of the bow and direction of the bow. It's x and y. Then it's similar is we define the bottom hole and bottom plate and same thing. Then we have two things need to consider. First, we should have a father or parent connection, and we have a children connection. The sub-connection is like a children connection. So first we need to pass the connection part, main part, to the sub-connection. Like usually if we have connection, we need to pick up member, like pick two pieces, then pick point, then using those information they can create a connection. So this is the basic. And also we need to give variable. So they have a user dialog to pass all the variable to the connection. But for the sub-connection, we are using a little different way. First, if anything want display direct to the further connection, we need to define them in global variable. So from here, we defined few variable. Let's see, you can see A, B, B, C, edge distance, bow space, plate thickness, and bow size, angle size. And this global variable was used inside the children connection. Then in the main connection, let's see what it looks. In the main connection, they will have a page that is from the children connection. So you can see all the global variable is displayed here. You can see AA, CC, BB, edge distance, angle, size. Then if you change it here or input any variable here, it will pass through to the children connection. And also they have another thing is the sketch. The sketch is when we have a children connection, you can see, let's see, we can select it. So this is the sub-column evacuate connection. So you can see the global variable is over here. Then we have a bow. So some of the variable already use the global variable. So the global variables value would pass through to here. But some of them, like the both standard, the type, and something else like the hole and material, this one is not showing on the parent connection, so we don't have a direct way to access it. So if we want to change, for example, we have some of them is material A36, but some is want grade 50. So what we need to do is we set everything here, and we save a name, say for example we say standard. So this is the standard setting. So this one is used on the parent connection. So what they did is first they will load this standard setting and get all the variable value. Then, well, any variable they have a global, it was a global variable. Then they will override to those standard setting. Then we can have different standard setting. Like say we have a standard 1 and standard 2. Then the standard 2 we can say material is different. Like say we can say material grade 50. Then we save to standard 2. Then in the main connection, in the parent connection, we can call the sketch standard 2. Then they will load the standard 2 setting first, then override it by the global variable. So that is how it works. So if you have a parent connection open and you want to set any variable inside the children connection, you can click the set subconnection detail. Click this one, they will call out the children connection. Then you can set any variable, any value here and save to a name. Let's say we can try say we change one of them, say angle. We just change some different material. Then we can say new standard, save. But remember, if we have anything setting here, if we select the connection and say modify, it doesn't work because this connection is independent. It's only when you save the file, save the setting, they only write to a standard file. And this file doesn't have direct link to the real connection. And when we save the setting here and we can close it, then go back to the main connection, they will have a new standard list here. So anything new they will add to this list. Then you can select the new list. Then you can modify. Then we can see material of the angle. See the material is changed. If we go back to the standard and modify, and we can see it back to A36. So that is how it works. And you can have a multi-level of children connection if required. So you can have like you click one, you go to one level 1 sub connection. If you have another sub connection, you can click again and save and modify. Then on this page you have to load the setting for its own tuning connection. Then let's go to the connection builder. We can see the connection, column splice connection. You can see the first 4 item is submin. That is for the sub connection. And for the first one, let's see the first one, edit. This is regular connection part. It's similar to the other one. And from the connection, we have all the connection available in this model list here. So you select the right one from the list. Then if the first time you apply, you have to close it, click OK to close it. You can add the main part and adding point here. Right now this 2 point is the vector, so you can use the browser to add the main part for the sub connection, and adding the point, use the formula maker to add the point to the sub connection. Then you have to click OK to close. The reason is once you load a sub connection, they should have a list of the global variable here, but this list is not flash directly for some reason, because for control the program speed. But when you close it and reopen it, they will load the list per the connection you're given. So from here you can choose, select one, click edit. So you have 2 options. You can select them to display on a user dialog if you check this on. If you check it off, they will not show on the list. And this list is the one, let's see, this list is the table here. So if you check the AA on, then they will show in here AA, and this AA is display name. So you can change it, say AA something else. And the formula here, if you say display input by user dialog, then the formula here is the default value. Or you can select, say, we don't want it display from here, but we want use a formula for it. For example, like say, oh, I want the angle AA to be something related to column flange thickness, like say column flange thickness +2. Then you can use a formula maker to make a formula. So they will not display on the user dialog. Instead, they will use an internal formula to do the calculation and pass the value to the tuning connection. Then also you can see, because the full connection is same, so we set the first one is master and give a share name, and the rest of them will be, say, slave, and they were using the same value as the first one. We have this the control from the sub connection, and once you setting, they will, and you close and open again, this one will replaced. And we have another one is loop control. this one is not used in this connection, but it was useful for something like ankle bow, or because ankle bow, for example, if we use an ankle bow as a sub-connection, they could have a lot quantity. For example, 5, 6, 8, 20, even 20. So we can give a loop for, like it was a array. So you can give a loop A, B, or you can give it based on by a bow. We will talk this for on the next connection. And let's go back to the first page. See, and you can see the direction of the input point. And the first point is Y plus and Z plus. Then we go back to the second one. You can see everything is same except the direction is minus Y and plus Z. And you can go to the third one. They were minus X, Y and minus Z. And the first one you can see it's plus Y and minus Z. So they gave everything is same except the direction is different direction. So by using this way, we will locate 4 symmetric ejection 8. So they will save a lot of time. And the rest one is just regular one. We just put some bow at web, lifting hole, end play, web play, prep, and we can see this one, the prep, beam prep. Beam prep is a special prep. Usually if we have a beam-to-beam connection, we can use end prep connection or end setting. That one including a prep for the beam top and bottom flange. But that one requires a interpoint. For example, the supporting beam or column, and the coming beam have an interpoint to the center line of the supporting beam. But for the splice, because they are on the same line, so they don't have any interpoint. In this case, we need a special one, say beam prep. And beam prep, they don't have a default work point and fitting plan, but you have to give the web fitting plan, or you can give different for the web top flange and bottom flange. So you can give your own plan, so that one is work anywhere as long as you can give a formula for it. Then the prep is prep and red hole for top and bottom flange, and also the web. It could have 2 web if for the tube. So if you have a special prep required, that's the one you should be used. Then you can see the setting here. So that is how the children connection works, or we say sub connection. So this is the first page setting. Then we have the rest. That's the regular one. Thank you.